Hello, hello. Yes, we welcome you back to this channel, Physical Sciences Silver Bullet, PSSB. And it's me, Richard, once again. So we are looking at this question. It comes from the rate of reaction. And let us look at the statement. The graph X below represents Maxwell-Boltzmann energy distribution curve at 500. So this is the graph we are talking about. This one. Okay. So we are having a number of particles here versus kinetic energy. And we are going to look at a series of questions which are going to come from here. I've picked this question from my book. And I have a book, a very beautiful book called Physical Sciences Silver Bullet. And this happens to be question number 1 from the chapter Rate of Reaction. Okay, let us look at the question. State what each of the following represents. The first one, energy Y. Okay. Energy Y is this energy. It was not indicated. I'm sorry. Yes, this energy represented by that bar. So what does that amount of kinetic energy represent? The answer is it represents activation energy. Okay. Then comes this question, question 1.1.2. It says, state what the shaded area represents. This happens to be the shaded area, the area after energy Y. And the question says, what does it represent? So this one represents number of particles, number of molecules, or number of entities, but with enough energy to react. Okay. Then comes this question. It says, what does the area under the graph represent? What does it represent? This is what we mean, the total area, this area until where the graph ends. What does it represent? It represents total number of particles in the system. Okay. Okay. That is that. So the area under the graph represents the total number of particles in the system. So let us look at another question. Then comes this question. Okay, let's first look at the statement. What does it say? It says that the temperature of the system is increased to 700 degrees. And the question says, which graph represents this energy distribution? Choose A or B and explain. Okay, when you increase temperature, the energy distribution changes from what this pattern we know of X. But the question, does it change to A or to B? So to answer this question, you need to know what the temperature does to the system. What does it do? It increases the number of particles with more kinetic energy. So generally, it increases the kinetic energy of the system. So you have to know that this is kinetic energy. And this kinetic energy increases as you move along this graph. What does it mean? That when you have a graph which has the peak more to the right, that graph is having more energy compared to that before. So between A and B, which one is having more kinetic energy? The answer is B, because the peak is shifting to the right. So the answer is going to be B. And why? The reason is going to be that B represents increase in kinetic energy of the system. So then comes this question. The question is 1.22. It says, state the effect of increase in temperature on the shaded area. So when temperature increases, what happens to the shaded area? This is the shaded area, remember? So if I increase the temperature, what will happen? Actually, the answer is going to be increase. When you increase temperature, the shaded area increase. You have to remember that shaded area represents the number of particles with enough energy to react. You can even see it here. If you follow graph X, it goes like this and passes here. But when you come to graph B, it goes like this one. So you see that graph B is higher. When you compare these two areas, the area for graph B on the shaded part is higher. So the answer is increase. Okay. Then comes this question. It says, use the graph to explain the effect of increase in temperature on the rate of reaction. So they want us to use the graph. And this is what we see. We are seeing that initially the graph was X, and when temperature was increased, the graph changed to B. And using these graphs, how do you explain the effect of this change on the rate of reaction? First of all, you have to know, let us look at the effect. What does it do? What does it do? If you increase temperature, what happens to the rate of reaction? Does it increase or decrease? Temperature happens to be one of the 6 factors affecting the rate of reaction. And when you increase it, the rate of reaction increases. So the rate of reaction will increase. That one is going to be the direction we are going to take. Okay, then they say explain. What is the explanation supposed to be? Why, when we increase temperature, the rate of reaction increases? So that answer lies here. Okay, what do we notice? When you increase temperature, the shaded area increases. And what does the shaded area represent? It represents the number of particles with enough energy to react. So that's the explanation. Increase in temperature increases number of particles with enough energy to react. Okay, let us look at that. Okay, so that is that. So temperature. So that is that. When temperature increased, the rate of reaction increased. Why? Increase in temperature increases the shaded area, which represents the number of particles with enough energy to react. Okay, let's go to the next question. Yeah, then comes this question. It says, use collision theory to explain the effect of increase in temperature on the rate of reaction. So already we know that when temperature increases, the rate of reaction will increase. What explanation does the collision theory give upon that statement? Okay, first of all, you have to know what collision theory is. According to the collision theory, for a reaction to take place, the particles must collide with the right orientation and correct amount of energy. So in this case, what does increase in temperature do? It increases the motion of the particles, the movement of the particles. That movement, we call it kinetic energy. So generally, you can say increase in temperature increases the kinetic energy of the particles. And when the particles are moving faster, their rate of collision will be higher. And you have to know that not every collision will lead to a reaction. So the collisions which are significant here are what we call effective collision. So effective collisions are those collisions when they collide, the particles will react. So generally we can put the statement and say that increase in temperature increases the frequency of effective collision, which increases the rate of reaction. So let us put it down. So that is that. We say increase in temperature increases the rate of reaction. And this is the explanation we have due to collision theory. It says that increase in temperature increases the kinetic energy of the particles. That one is very important. The keyword here is this one, kinetic energy of the particles, which increase the frequency of effective collision, leading to increase in the rate of reaction. So technically, this is what you're supposed to know. So we are going to cut this video here because we don't want to produce long videos. Other parts which are coming out of this question will be covered in the video in the part 2. We have to remind you that the channel is PSSB, Physical Sciences Silver Bullet, and it's me, Richard, once again. See you next time. Bye.